Okay, so here we are trying to finish question number 10. This is a really hard one. So let me finish up this rectangle part here. So it says a rectangle. So which of these categories... So I've crossed out, notice down here, I've crossed out a bunch of categories that are actually impossible. Talked about all these on the previous YouTube, if you want to go back there, 11.2 part 2. This is 11.2 part 3 now. Okay, and I want to add to this a rectangle fits category F, a rectangle but not a square, but it's also a rhombus. I'm going to put in here J. F and J both go in there. How's a rectangle a rhombus? Remember, rhombus just means four. Oh, no, wait. Oh, no, that's actually not true. Sorry, my mistake. A rhombus has 4 equal sides, so it's not a rhombus. Let me take that back. That was a mistake. Rhombus has 4 equal sides, but it is a kite. K. Why? Because what's the definition of a kite? A kite has 2 sides. You know, a kite's like this. And, you know, this side and this side are the same, and this side and this side. Well, a rectangle has that, right? Oh, no, he doesn't. He doesn't have that either. I'm mistaken. I just keep thinking, no, it's not a kite either, because the 2 sides, like these 2 sides that are next to each other, are not equal. So, no, he's not a kite either. So he's just case F there. Let's go on to this one. This one down here, it says BA equals BC. We see the mark here and here. And the other 2 are not equal, and it's not a trapezoid. And so, that one doesn't seem to fit any of our categories, does it? It's not coming down here to it's not a trapezoid, it's not a rectangle, it's not a rhombus, 4 equal sides, it's not a kite, so it's nothing. This will be nothing. Kind of like this one was also nothing, no place. All right, coming down to the square. Now, what is the square? It's going to fit several categories. A square, first off, it can't fit here a trapezoid, but not a parallelogram. A square is a parallelogram, so it doesn't fit that category. It's, how about the next category? A rectangle, but not a square. No, it is a square. How about a rhombus? Yeah, it's a rhombus because it's got 4 equal sides. A rhombus just has 4 equal sides. And is it a kite? Yeah, it's also a kite because 2 sides that are next to each other are equal, which is the definition of a kite. Remember, again, a kite is like this. 2 sides next to each other equal. The other 2 sides next to each other equal. Well, that's true of a square. 2 sides next to each other equal. Other 2 sides equal. It's technically a perfect case of a kite and a perfect case of a rhombus. So a square is a perfect rhombus and a perfect kite. So it technically is a rhombus and a kite. Next one. This is, it's clearly a trapezoid. Top and the bottom are parallel, so it's a trapezoid, but not a parallelogram. That's exactly what it is. Trapezoid, but not a parallelogram. Last one here. This one is a parallelogram. All 4 sides are congruent. So what does that mean? Let's go through the list. Is it a trapezoid but not a parallelogram? No, it's clearly a parallelogram. Is it a rectangle? It's not a rectangle. Is it a rhombus? Yeah, all 4 sides are equal, so it's a rhombus. Is it a kite? Yeah, it's also a kite, because remember, a kite has 2 sides next to each other equal and the other 2 sides next to each other equal. Yeah, it fits those 2 categories. So that's a very tricky problem. There we go. Okay, number 11. So choose the correct classification for A there. So looking at that triangle, what is that triangle? It's acute, right? All the angles are less than 90, and it's equiangular. All the angles are equal. How about B? That one, that angle looks bigger than 90, so it's obtuse, like that. And then C, let's go on to, I guess we don't get the picture. Oh, wait, I did the wrong one, didn't I? Let me be a little more careful here. This is B. So this one down here is C, which is obtuse. What was B? B is a right triangle. There we go. I just didn't notice the pictures. All right. And number 12. Are all equilateral triangles isosceles? Yes. Yes, because according to the definition, isosceles have at least 2. Remember? Isosceles has one or two. Let me see if I go back. We can just go back to the definition where I wrote it. Wait, where did I write that? No, wait, forward. Here we go. There it is. See isosceles right here? Isosceles has two equal sides or three equal sides. Two means two or more equal sides. So an equilateral is a perfect isosceles. It's a kind of isosceles, a perfect isosceles. So that would be a yes. Down to here now, determine the measure of the angle's turn symmetry. So for this figure, how far can you rotate that figure and have it come right back onto itself? You can rotate that figure 180 degrees, right? Turn it halfway over. Make this bottom go up to the top there. 180 degrees. Let me get rid of this stuff. Turn it 180 degrees, and it'll be back unto itself. Just flip it over. 180 degree rotation symmetry. Now how about this figure? How far can you rotate that and have it go back unto itself? Well, you can take this part and rotate it to there. So that'd be 90 degrees. But you can also rotate another 90, so that'd be 180. Or, right, you can take this part down to there, that'd be a 180. Or you can take this part all the way over to there. It's going off the screen. That'd be 270. Right? Any of those. You can turn it 1/4, 2/4, or 3/4, and it'll be back unto itself. And of course, 360, turn it all the way around, but remember, we never count 360 because any object, you turn it all the way around, it's back unto itself, of course. We're only interested in angles less than 360, that we can turn it less than all the way around, and it's back unto itself. Oh, I guess there was more room there. Okay, so on to number 14. A student claims that all figures with four congruent sides are squares. Is that true? All figures with four congruent sides are squares. No, because, here, let me, right, rhombus. Right, the angles are not 90 degrees. All four sides are congruent. It's not correct. A figure must contain four congruent sides and four right angles to be a square. That's true. Right? So there we go.